The government has confirmed that plumes of dispersed oil from BP's leaking well are spreading far beneath the surface in the Gulf of Mexico. The National Oceanic Atmospheric Administration said some of the most toxic components of the oil are not necessarily rising to the surface, but are drifting through deep water in plumes that stretch some 50 miles from the gushing well. The admission by the government agency confirms what scientists have been warning for weeks and renews concerns about the catastrophic impact of the oil on marine life. Last week, BP CEO Tony Hayward had declared, quote, "The oil is on the surface. There aren't any plumes." Meanwhile, Tuesday, BP and government officials claim BP's new CAP system has collected over 51,000 barrels of oil since Friday. On Sunday, Tony Hayward told the BBC he's hopeful the new measures would soon contain a major portion of the oil gushing out of the ruptured well.
As we speak, the containment cap is producing around 10,000 barrels of oil a day to the surface, which is being processed on the surface.
So what sort of proportion is that of coming out?
At the moment it's difficult to say, but we would expect it to be the majority, probably the vast majority of the oil.
So you think this cap will get most of the oil?
Well, that is our hope. We are optimizing the operation. We have a further containment system to implement in the course of this coming week, which will be in place by next weekend. So when those two are in place, we would very much hope to be containing the vast majority of the oil.
But a member of the government panel determining the size of the spill says 10,000 barrels of oil a day could only be a fraction of the total amount of oil spewing out of the BP's blown-out well. Scientist Ira Leifer says the oil may be gushing out at a rate of more than 100,000 barrels a day, a number BP once called its worst-case scenario. For more, Ira Leifer joins us now on the phone from California. He's a researcher in the Marine Science Institute at the University of California, Santa Barbara, a member of the government's flow rate technical group. We welcome you to Democracy Now!, Professor Leifer, Dr. Leifer. Explain what we are not hearing from the government or from BP.
Good morning, Amy, and it's a pleasure to be on Democracy Now! I've been a long-time fan and listener. The flow rates, we've now been provided some good data, which has been very difficult to come from before. And this data we're analyzing, in its absence, what I pointed out is that there's no reason to disbelieve BP's worst case, and that it could be very large in the 100,000-plus range for a freely flowing pipe, which it clearly appears to be. Now, we're going to find out what the flow rate is, at least as best as we can with the data that we've been given. But I'd like to point out that this is not scientific data that was collected to figure out how much flow, but this is actually data that was just from monitoring, which we're going to try to use, and that means there's going to be larger uncertainties than I think anyone would like. And in particular, these uncertainties mean that the ability to, as Tony Hayward suggests, to hopefully contain, we won't be able to know as precisely as people would like to know whether this is going to happen, whether we will be able to contain the oil gushing into the Gulf, or whether, in fact, we'll be able to do this safely. And so one of the things that I've been proposing and other scientists have proposed is to actually measure the flow using available techniques so that any activities that go into the future can be done safely.
So explain again what you think the numbers are, and this whole idea of the U.S. government using the lower estimates, the lower end of the scale, and never mentioning that that was just on the spectrum and that there's a higher end as well.
Somehow there was a miscommunication, and the report that we had written, which said, based on the data, we can only come up with a lower estimate. The data is such low quality, we don't know what the upper estimate is. Somehow that was miscommunicated and released as the full range. And immediately, the University of California put a copy of the original document on our website to make it available for everyone to see and compare. And within a relatively short time, many of the statements coming out of the administration some of them began to reflect the new, the correct interpretation, which was what we had said. But the other thing, and this is one of the issues I'd like to try to clarify with the audience, this is not, it's not a pipe coming out of a big tank. It's a very complex geologic system underneath, and it's also being affected by activities of BP. So the flow today is not necessarily the flow tomorrow, and it's hard to speak of a precise number like this is the flow. So, for example, we have from previously 45 minutes of video from BP, and from that we were able to estimate, and should be released very soon, what our range of flows is. But that only reflects that 45 minutes. We do not know what was happening 5 minutes before. We do not know what was happening 5 minutes afterwards. And this is and worse is that from looking at the satellite imagery of the evolution of this oil slick strongly suggests that the emission rate has been increasing since the incident occurred. And one of the things that, of course, has been happening is that various efforts to attempt to stop the spill could easily have had the effect of allowing greater oil to come in. So what I'm trying to say is it's a moving target, and we're trying to actually even keep up so that the next strategies are appropriate.
So the lower bound range, 12,000 to 25,000 barrels of oil a day. The higher range, 100,000 barrels a day. That's more than 4 million gallons a day, Ira Leifer?
It is in that range, and while there's no way to say for sure that the system is, in fact, dumping that much oil into the Gulf, from a geologic point of view, from a freely flowing pipe, there's no reason it could not. This reservoir is massive, and it could easily flow that kind of oil for the next 20 or 30 years if it was left to go unattended. So the amount of oil that could end up in the environment if measures are not successful is at what I would call unimaginable.
Could they just bomb the hole? Bomb the hole where the oil is gushing out?
One of the concerns, which has been released, and so I can actually talk about, but there is concern that the rock structure surrounding the pipe is not as strong and could, in fact, give out. And for I guess, many of your very long-term listeners might remember, but in 1969, something like that happened here in Santa Barbara, where the oil, instead of coming up the pipe, went through the seabed and the rocks and came out of the seabed, and in many different areas. It's a much harder problem, to do and to solve because you don't have a single pipe to kind of seal. So one of the very big concerns of such a suggestion is that if that damaged a rock structure around the well pipe, the oil could come right through the seabed, and instead of a leak from a single point, we could have hundreds and hundreds of small leaks spread out over a large area, moving around. Sealing those in 5,000 feet of water, making a cement pad, is so much harder.
Why is only BP monitoring the spill size? Why aren't you the scientists?
I think that's an excellent question, and this is one of the areas that I and other team members have indicated. If we are to learn from this oil spill so that when there is another one, because the reality is that you can't engineer accidents away. There will be accidents no matter how much we try to prevent them. And the key, of course, is that when there is an accident, you don't let the damage occur. You keep the passenger and the automobile safe. You keep the ecosystem safe. And the scientists have not been able to come in and actually make the measurements so that we can learn from what happened, so that when there is another accident somewhere on the planet, the best science and technology can protect the ecosystem, and we would be talking about a small but still horrible spill rather than the very large one that we're currently faced, where we don't seem to have any good ideas to really how to stop it.
Has the U.S. advanced in how it deals with these spills from decades ago? So
the answer to that is that the advancement has been painfully slow. During the event of a spill, typically, as we're seeing now, the scientists are kept away. We have to stop the spill right away. We don't have time to let the scientists come in and take a look. We scientists will come in after the fact, much later. There's government support for a few years, and then it completely dries up. And little bits of research still continue,